and we store that into a xtrain and xtest, ytrain, ytest. So we used 80% of the data as the training data and 20% as the testing. And of course, since this data is pretty small, and we just randomize it and do this one times, and it would just be suffice. And then let's actually start training our model. So essentially, the linear regression is using the sort of the best or minimize the variance. Let me just draw you a thing. Okay, so let me let's just draw something. Okay, so essentially, let's just get you I think that's easier for me to explain it. So this is just 2D dimension. Okay, so 2-dimension x and y, and you got all sort of a data scattered around on it, and this is the data that you are going to train your model. Okay, so if you want to have a model that get most of all the information in this series of data points, you're going to minimize the variance, and of course you're going to sum all that up. So we call that ordinary least square, but I don't want to get too much of the math in it, so you just need to know the theory behind it. So essentially, just to get all the data, you calculate all that, the difference between this data points. So we got say this, we got a y, a certain y, or y slash, something like that, or maybe y1, something like that. Okay, so this is the real-time data, and this is the predicted data of the y, and you calculate the difference between them. And because sometimes the difference is a positive value, sometimes it's a negative value, so you don't want to get the absolute value, because in mathematics we hate absolute value, so we just square that. Okay, so this is just a simple way to get rid of this there, because we need that the formula to be continuous, rather than just to split it up, and you need to say input an if and else statement, something like that. So you just need to square it, and you can sum it all that up. Okay, we sum all the square up. So I try to avoid all this mathematical symbol here, just using the simple high school math to explain all that to you guys. Okay, so because you don't need to get too technical about things, you just need to know that I use this method called ordinary least square. Okay, just to sum all this square difference up, and make sure that this line, and just remember, this is not just one line here. You may just test a lot of line. Okay, so you got this line, and every line you're going to calculate that, and you are going to choose the line that minimized this sum of the differences, and that will be the best fit. Okay, so as long as you know this model, and what I'm going to do is to use computer to automatically sort of a streamline this process, just in just one line of code. Okay, if you're interested, I also got a GitHub repo. Just use pure Python without depending on any of the library to actually do that. Just use some pure mathematics and pure Python to do that. You can also look at that if you want to get nitty-gritty detail about it. Since we're using sklearn, and sklearn is a pretty powerful scientific library, so you can already all the powerful data scientists already write that algorithm for us, and it's pretty efficient. Okay, so don't invent the wheel, because other people already do that, and it's much more efficient than you you invented it yourself. Okay, you might invent a square wheel, but other people will already get a pretty efficient wheel. Okay, So let's just use them. Okay, so from sklearn and dot linear model. Okay, because it's just a simple linear regression, I'm going to import this linear regression model. I think we already import that maybe at the beginning of it. Yeah, this is just a plotting model, so yeah, let's import that again. And model selection, train test split, and yeah, linear regression model. And then let's run it, and it did not give us any error, which is a good thing. Okay, and I think we need to add in a little bit explanation here. So import the model that can automatically find the best fits. Okay, and yeah, because I already restart this environment, so what I'm going to do is to use runtime and run everything. Okay, so yeah, we haven't uploaded the data, because yeah, every time you restart the service, you just get rid of the session and restart that these places that you just uploaded will just be gone, so you need to re-upload it. So do remember to store some of the info into your local computer. If it's pretty big, say many gigabytes of data, especially in the deep learning, it's pretty common for you to have a pretty huge amount of data, especially the image or non unconstructive. It's not data do not have certain structures. You might get pretty large. Then you may need to upgrade your Google Drive and upload that and reference that to the Google Drive. But we will come to that when we add the deep learning. Since we haven't uploaded that, I'm just going to pause this video and upload that to save you guys a little bit time. And as you guys can see, it already give us a warning that the runtime file will be deleted. Okay, so I already uploaded and I can run it all. Okay, so the previous variable will got the data that we would like. Okay, and then let's run all. This time I think the xtrain will got the info. And it's pretty strange, we did not get the extra info because I think we already train test split. Yeah, we need to output this X train and Y train info to that. I think maybe last time when we got that and just delete all this code and add that. And I'm not going to edit this out because it's a common mistake that some student may have encounter. And so if you edit the code and you run that, sometimes it can work, but when you restart the whole service, this may not work. The reason for that is that the last time it worked because if you edit it, there's still a backend server running. So even though you added it, it still remembers and store that temporarily, but you need to make every step count. Okay, so you can't edit the previous step because if you rerun that, the runtime will just erase every time. Every time it runs, just erase previous time. So you won't store that. Temporarily stored information will be just erased. Okay, so what I'm going to do is to I think it's a good idea to add some code here. Remember to run this first because you need to store that in xtrain first and then quickly just run that. Okay, let me quickly do that. Xtrain and ytrain and xtest, I think. Xtest and ytrain and ytest. unscroll it, and that would be our I'm going to call this train test split and input this x and y, and test size would be 20%, so 0.2, and we're going to have a random state of let's say 1 maybe, or 9, just for luck. Okay, so if you run that, it will have no error, and then you run x train, you will get you the info. Okay, and x test, y train, y test will get all sorts of info, and then you can import that fit model, and after that you are going to get a certain model. So the linear model say 001. Okay, of course you can use camel casing, or you can just camel casing should be something like this. Okay, so the next letter or every letter next words every words that is shown behind the first one will be capitalized, so easy to learn. Of course you can use the underline, and it all depends on you, but just to be consistent. Okay, and that model would be, let's use the linear regression to fit that model. So essentially this is a generate a model instance, would be a linear model 1, and that will be the model that we are going to train it. Okay, so we're going to get that model, and we're going to fit all this data inside it. So we got this x training data and y training data. So we're going to put this data inside and train our model, right? Okay, once you put it, you're going to find the best fit. Just the computer will automatically find that best fit for you, and this will give you output saying that the training is complete. So yeah, we are going to predict it. So the model, this is the model that we already trained. Okay, so we already fit that, and we're going to use this model to predict the info. Okay, so we get hold of this model, and we can use this is like an instance of that model. Okay, so you're referring to that model, and you can just use that to predict data. Okay, so we can dot and predict. Okay, and we need to pass the we already got this test data, which will be x test. So you're using x test to get a prediction, and you're going to compare this prediction with the y test. Okay, so you're going to compare that, so you know the accuracy, so you can score it. Okay, so you use that test data to predict, and once you got that, okay, you got the prediction, and this will be a prediction. Okay, so you're going to have make this prediction and sort of store that in a variable. So the prediction results. Okay, prediction results, and preferably you're going to use this y prediction result, something like that. Okay, or maybe something like this, y predict, which is in camel casing you're using underscore. Okay, so y prediction predictions, okay, will be this, because you use that model instance, you predict that using the x test dataset, and you get to get that prediction, and you store this array of prediction into the prediction. Okay, so that's basically how you are using the data to train your model, and to using them the trained model to predict using the test data. Right? And next time we're going to use this prediction to compare whether your model is good or not.